Good morning to all. This is in continuation with the previous topics of operations on time signals. So just so far we discussed three important operations on signals. These three are time shifting, time scaling and time reversal. Now in continuation to the topics, we are starting our next topics. Now, regarding the, now we discussed operations on this one. Actually, signals are actually two kinds of signals. And the signals can be described in two ways. One in continuous domain. One is in continuous domain. Another one is in discrete domain. Discrete domain. So, classification of signals are different, types of signals are different. Just now we are discussing what? Classification of signals. This is called what? Classification. Classification of signals. So, signals are of two classifications. One is called continuous time signals. Another one is discrete time signal. Continuous time signal, discrete time signal. These two are different classifications of signals. Students have to understand like this. Now, so far, for your understanding purpose, at the beginning, just I described about only continuous time signals. In the same pattern, now we are going to discuss discrete time signals as well. Now, continuous time signals means we have to use the mathematical representation of integration. Integration means what? It belongs to a particular some period, a comma b. This is the continuous notation. Closed interval. This is a symbolic representation of continuous time signals. This is the mathematical representation. You are very much familiar with the mathematical integration concept in your intermediate paper 2B. Now, regarding discrete, now we are using summation, symbolic representation. So, students have to distinguish between these two signals. One is continuous time signal, that is denoted by integration, integral of. Now, here this is summation. Here this integration means what? Continuous means what? It will be described at each and every point. At each and every point, that is called continuous. But discrete means what? It is only at integers. Points only, points at, it describes only points at integers. Only integer points. Integer points. For example, look at, suppose, this is a signal. A signal width is, for example, 0, 3. 0, 3 means what? It not only takes the values of 0, 1, 2, 3, but all values. For example, look at 0, 3 means what? 0, 1, 2, 3. It is closed interval. It not only takes the integer values 0, 1, 2, 3, but also takes every value between 0 to 1 and every value between 1 to 2 and every value between 2 to 3. This is called continuous. Wherever we use the word continuous, this continuous word is applicable with the mathematical notation of integration. Now come this one. Take the same. Here in discrete, we don't use the variable t. Instead of, we use the word n. That is called n. N is between 0, 3 means what? It is written as 0, 1, 2, 3 only. Now just look at the difference between the two notations of these two observations. Here only we use the closed interval, mathematical interval. Here we should not use interval because it represents this value n is only for the values of at 0, only at 1, only at 2, only at 3. But now just look at like this: 0, 1, 2, 3. Actually, between 0 to 1, so many points are there. Between 1 to 2, so many points are there. Between 2 to 3, so many points are there. But it never considers these values. It only considers integer values 0, 1, 2, 3 only. Now look at that is the difference between continuous time signals and discrete time signals. These two differences students must remember. Again, just I am repeating this one. Just look at classification of signals. Classification of signals can be continuous time signals and discrete time signals. Whenever we are using the word continuous, it is represented by integration. Whenever we use the discrete time word, we use summation. This is called summation. This symbol is called summation symbol. That is called sigma. Summation symbol, sigma. Sigma. For example, just look at x of t belongs to 0 to 3. Now, in this case, this is continuous because of closed interval. So, we have to use the calculation purpose, integration, the starting value 0, the ending value 0, 3 of, for example, given signal x of t dt. We write like this, x of t dt. For the same here we have to write, look at summation. Here we have to use x of n, where n is equal to 0 to 3 only. Now look at the notations between continuous time signals and discrete time signals should be clearly understood before entering into the discrimination or differences between these two sketches of signals. So here in this concept, again just look at this is the classification, come to the left branch. In this classification, come to the right branch, just like our binary tree structure in computer algorithm data structures. Now come here, this continuous time signals, this is denoted by integration. Integration means what? Continuous. Continuous means a closed interval between A to B. There is the width of the signal, starting point and the ending point of the width. Now, each and every point. Here, this integration belongs to each and every point. Here, in this way, for example, this is for example, if the signal width is, this is example, the signal width is between 0 to 3. Now, between 0 3 means what? Between 0 3, there are two integers, 0, 1, 2, 3. This integration continuity means what? Not only considers pure integers, but also considers each and every decimal point. Each and every decimal point, the notation is like this, 0 to 3, x of t dt. This is the way of calculating the signal power or energy in the next cases. Now come to right branch. This is called a discrete time signals. Discrete time signals denoted by a symbolic representation that is called summation. Summation means only at integer points. It is only at integer points. Here x of t, now just look at, here x, how we are writing this one? Here we are writing x braces t like this. It is a parenthesis phase. But here we have to write the same x, name of the signal, but here we are using a square brace of n. Look at the differences between these two. Before addressing the remaining topics, we have to make it look at the differences students have to remember. In case of continuous time signals, we use this notation only. In case of discrete time signals, we use this notation only. Don't swap this notation with this notation or either or, like this only. So these are clear-cut notation. Here only just whenever we are using discrete time signal, it will be summation and the description will be only at integer points. In no way decimals will be taken place. But here decimal values are also taking place here in the continuous time signals. So these two are the classification of signals. Classification of signals. Then the next one, now we are going to discuss types of signals. Now just the next topic. We are types of signals. This is the types of signals. Now students have to make a clear-cut distinction between these two. This is classification. Those are types. Classification is different, types are different. These two, students have to make the difference between these two. One more point, before entering into types of signals, just classification means we are dealing with only continuous time signal and discrete time signal. Here integration, there is summation, here all points, here only integers, here x of parenthesis of t, here x square base of n. Here we use the variable only t. Here we use the variable n. This small n describes discrete. This small t describes continuous. These two are the differences between these two. In the next topic now, just we are going to start with types of signals. Types of signals means what? Various kinds of signals. Types of signals means what? Various kinds of signals. Various kinds of signals. That is called types of signals. Now just we are going to start with. Thank you.